Electronic systems are often responsible for controlling motors, solenoids, heaters, and other types of high-power equipment. The thing being controlled is called the load, and we control it by turning it on and off. The commands that control an electronic switch will frequently come from a microcontroller. We can't use the microcontroller to directly control these loads though, because the signals generated by microprocessors and other types of digital ICs cannot supply the large amounts of current required to drive high-power loads. Discrete transistors, on the other hand, can supply large amounts of current. If we insert BJT switches between the microcontroller and the motors, we have an effective method of controlling high-power loads by means of low-power digital signals. When we use a BJT as a basic low-side switch, the goal is to turn the load off by preventing current flow, and to turn the load on by allowing current to flow freely from the supply voltage, through the load, through the BJT's collector and emitter, to ground. Preventing current flow is easy enough. A logic low control signal will not forward bias the BE junction, and thus the transistor will be in cutoff. But how do we allow current to flow freely through the load? Do we want an on-state transistor switch to operate in forward active mode or saturation mode? In a switching circuit, we simply want to drive the transistor into full conduction. Thus we transition the BJT between cutoff mode and saturation mode, and we don't limit the input voltage or the input current in an attempt to keep the transistor in forward active mode. This plot was used in a previous tutorial, except the labels have been changed to help us understand why saturation mode provides maximum current to a switched load. The collector voltage, VCOL, decreases during forward active operation and levels off when the transistor enters saturation. We approximate the saturation mode collector voltage as a constant VCE sat equals 0.2 volts, and we think of VCE sat as the lowest collector voltage that is possible during normal operation. If we imagine that the load is a resistance placed between the supply voltage and the collector voltage, the current through the load will be greatest when the voltage across the load is maximized, and since the supply voltage is fixed, voltage across the load is maximized when the collector voltage is minimized, which is when it reaches VCE sat.